Go again.
I'm Bjorn Hansen,
And I'm Nikki Madigan.
and we did the water levels of White Bear Lake.
So we decided to choose this topic because we're both interested in lakes. Also, it's really relevant to Minnesota since we are in the land of 10,000 lakes. And it's easily connected to Calgary.
The history of White Bear Lake, it's one of the largest lakes in the Minneapolis area, and recently it's been dropping very rapidly. It's lost about 6 feet of water total, so the shoreline has moved hundreds of feet. So like lakeside homes are no longer lakeside homes, and there's a lot of towns pumping the water from this lake.
So from 1900s to like present day, the level of White Bear Lake has been decreasing, and the DNRs think it's because of that it's climate related. The lake mostly depends on precipitation and an aquifer that's in the groundwater. The aquifer supplies the water to all the surrounding cities around White Bear Lake and White Bear Lake itself, and also like the businesses and golf courses around the area. So it's using up so much water that from the aquifer that the aquifer is starting to take water from the lake, which is why the lake is decreasing, but that's not what the DNR thinks.
The water level of White Bear Lake is really important because there's a lot of money tied in with the lakeside homes being worth quite a bit of money, and if they're no longer lakeside homes, they lose a lot of money in real estate. And then also just for pumping water into the surrounding towns, a lot of people depend on the water from White Bear Lake in the Twin Cities. So if they weren't able to pump from there, they would have to find a new place to get water, which would be extremely expensive, upwards of hundreds of millions of dollars.
So by using calc, we found like the rates of which the water was leaving and how much water was leaving.
And the history of this math was made by Isaac Newton and Leibniz, and they're credited with creating calculus and making derivatives and integration. And their key idea was that derivatives and integration undo each other.
So we created a tangent line to figure out at what rate the water was leaving at. It started at around 2012 at about like 1 foot of water per year.
And then you can estimate instantaneous rates using a secant line. So we took 2007 and 2009 and used the data here and made a slope, find the slope. And in 2008, you can estimate that it's losing about 0.7 feet of water per year.
We also found the area of the surface area of the lake. And finding the surface area of the lake, we estimated the volume of water that was being lost. When we were estimating, we found out that White Bear Lake had lost about 4 feet of water.
And then knowing the surface area is 8.66 miles squared, you have to convert that to feet squared using this. A mile is 5,280 feet long. So you square that and then multiply by 8.66. So then that is that, and then you integrate from 0 to that, and then with the 4 feet lost, it's about 9,065 gallons lost. And this would be an over approximation because that would be assuming that the lake is like a pool and it's a straight drop off, whereas it's like a gradual incline in depth. So that's an overestimate.
We figured out that derivatives could be used in other areas, like finding the acceleration of cars. Also, we figured out
They can be used to, know, if you have the acceleration of gravity, you can integrate to find the velocity of the object dropping. And then if you integrate that, you can find the position. So then if you know the position, you can take the derivative and you know the velocity, and then take the derivative and you know the acceleration.
So like all those tied together.
And then you can also use derivatives to find air pressure, and then how much of a substance, how much of the concentrate is in solution in chemistry. So it's used in many different scientific and mathematical areas. And then they are used in physics in terms of time and force, and you can find how much potential energy there is in an object, like gravitational potential energy, and then the derivative will give you the amount of force supplied. And then they're also used to optimize production. So if you're creating goods on an assembly line or something like that, you can find out how many you would produce to find or to have the maximum profit.
Integration could also be used in other areas, like to find volumes of barrels, or like finding the volume of a barrel. Companies use that so they could figure out how much product could be fit into it. Integration can also be used to find the displacement from velocity. So you would know the position of the object, and also integration can be used to find the rate at which objects cool.
And then these are all of our sources. We use the DNR and different journalist sites to find out how much water they're losing. Use some math sites to find out how we can apply that math to other areas.